Hi, welcome to the third video in the wave function collapser video documentation. In this video, we're going to take a look at some of the code behind this generation. Just to recap, all of these roads are actually slots that have already had their modules defined and then generated into meshes. So at the top of the example, there's a road demo behavior. We're going to take a look at this script. So we can see at the top, we have three class variables that we can set from Unity. The first and most important one is the wave function collapse config that we talked about in a previous video. The next one is a prefab reference that we use to spawn for each slot once it's collapsed to a single module. And the next one we'll get into in a second, but it's called the frame budget time, and it pretty much controls how quickly the wave function collapse algorithm is allowed to run in your game. There's the standard Unity start method, and there's two major steps that we do. First, we create a generation space from the wave function collapse configuration. So every time you call the create function, you're going to get a brand new copy of the generation space. And it's going to have all of the slots and modules pre-configured from what you set in the inspector. The space that we get back, we can just call collapse on it. And that's going to go ahead and actually start an operation where every single slot will be collapsed to a single module. In order to execute that, we're going to run it as a coroutine, and we're going to run it as a coroutine off of the game object that we pass in here. And then we also pass in this frame budget time again. So if you pass in a really high number as the frame budget time, then you're going to allow the wave function collapse algorithm to run many iterations in one frame. And that could cause a lot of lag because you're going to be spending a lot of your frame cycle on this algorithm. Instead, the algorithm has been designed so that it can be interweaved with render frames or any other events that you want. So if you pass in a low number, maybe like 0.1, then only 1/10 of a second will be allowed to go by before the wave function algorithm has to stop, and the rest of your code can pick up, and most importantly, you can do a render frame. As the algorithm progresses, we want to spawn road tiles for every slot that is collapsed. This callback here is going to run every time that happens. Every time it does happen, we're going to get the slot that's collapsed and the module that it's collapsed to. And in this case, we only care about modules of the type sprite config module. So in here, this is pretty boilerplate Unity code, but we'll go ahead and instantiate our prefab, then reach into the mesh renderer, set the texture, and then also just set the position based on the width and the height and the slot coordinates. And then we have one additional callback just to print out when the wave function has completed. There are a few other things worth noting about this code, and to show them, I'm just going to delete all this and start over again. I'll keep the generation space. You'll notice on the generation space, there are all sorts of things that you can use to inspect the state of the generation space as it's going. So there are different methods that you can use. You can collapse just one slot if you want, and you can decide whether you want to collapse the lowest entropy slot, or a slot with a specific module, or like we were doing before, you can call collapse, which will just collapse the entire generation space. And when you do this, notice that this actually returns an IEnumerable of wave function collapse progress. So if I do that, then in this case, this won't actually run the algorithm. First, you need to decide whether you want to run it inside of a coroutine, like from earlier, or if you want to run it immediately. It's not advised to run them immediately because, as stated before, it will cause quite a bit of lag. So instead, I'll run the progress enumeration through the run as coroutine function like before, and we just need to pass in a game object reference to attach that coroutine to. And then I'll also go ahead and pass in my frame budget time. This method returns a progress observer, so let's capture that in a variable. And on the progress observer, there are different methods that we can use to keep track of callbacks or state. So before, we were using onSelected module. We could also attach just a general progress callback that would fire if there was any sort of progress, like a selection, or a module of removal, or a propagation, or in the event, an error. You can also attach the complete, like we saw before. And then the onSelected module has a couple of different variants that are worth noting. The progress observer also has a couple of stateful things that you can keep track of, like an isComplete boolean, how much progress has been done, and any selections that have been made at this point. So one thing that you could do is actually hold a reference to the progress observer under class, and then in the Unity update method, you could check those stateful conditions there. That wraps it up for how to use the wave function collapse configuration objects and how to actually run or collapse the generation space.